One, day 4 of the joint W3C OGC Maps for the Web workshop. And we're going to be starting the agenda tonight with on the topic of creating accessible web map widgets with 2 presentations. The first from Nic Chan, who will be presenting her and Robert Linder's work, who are Robert and Nic are both members of the Maps for HTML community group. And they've done a review of and evaluation of various web mapping libraries and compared them with the web content accessibility guidelines, and she'll be reporting on their work. And then we're going to proceed to an introduction to digital non-visual maps from Brandon Biggs of Smith Kettlewell Institute. And after that, we'll have a breakout. Hello? After that, we'll have a breakout presentation from Brandon about building cross-sensory maps using Audiom. And at that point, we'll cut over and I will finish my part 2 of the MapML proposal and maybe give a little demo of our custom element suite that we've been developing in the Maps for HTML community group. So I'd like to just remind everybody that we welcome lots of interaction on Gitter and Discourse in particular. Get lots of comments and feedback on people's presentations through those avenues. And I hope somebody will paste the links in there so that it's easily to get to. And the comments can come anytime, so we can do it 24/7. And also, I just remind everybody that we have a code of conduct that we're following, the W3C code of conduct, and you're free to express yourselves in a polite and respectful manner and all that. And if you feel that you have not been treated in a fair way, please approach one of the committee and we will do what we can to address your concerns. So with that, I'm going to play Nic Chan's slides. So maybe I'll share my screen, and Nic has recorded her presentation. So I will switch over to that. And share and optimize. And here we go.
Hello everyone, my name is Nic Chan and I have been contributing to the Maps for HTML community group over the past year, with a particular focus on the use cases and requirements report. Today I will be presenting on the accessibility of existing map widgets and tools. Before I get into the details of the analysis, I'd like to lay out some definitions that will frame this discussion. The map tools discussed today fall into 2 general categories: widgets and client-side mapping APIs. Widgets refer to an embeddable map, typically in an iframe or something similar, that requires minimal code to implement. These include things like the Google Maps embed that small business owners may use to share their store location. Client-side mapping APIs are JavaScript libraries that allow website developers to create more customized map viewers. They typically require the developer to do more configuration and instantiation work, with the benefit of offering more control over the end result. You would typically find these as a part of web apps like store finders or delivery services. In this presentation, I'd like to frame accessibility as the degree to which these maps are usable by disabled people. Some contexts may use the term accessibility to encompass other things, like cost and size of these tools and how that pertains to access, but in this case we will be focusing on the usability aspect, and especially how these mapping tools measure up to our next term, WCAG. WCAG, short for Web Content Accessibility Guidelines, is a series of guidelines developed by the W3C in order to provide a shared standard for developing accessible web content. It is important to note that the WCAG is not the be-all and end-all of accessibility. When it comes to things like maps, a tool could meet every single criterion but still not be accessible. There are many outstanding questions, which will be discussed in greater detail by other presenters and panelists, about what would constitute an equivalent experience to what a map can communicate for low vision and blind users. However, it is still worthwhile to examine the existing tools with the WCAG in mind, so that we can account for other disabled users beyond low vision and blind users, such as people who have motor impairments. By looking at these existing tools, we can determine any common patterns worth adopting for a native HTML map element. Not all WCAG criterion are relevant to web maps, so I've pulled out some of the most applicable and interesting ones, where the map tools meet these criterion with varying degrees of success. Tools reviewed. The tools today include both widgets and libraries from vendors like Google, Bing, Apple, Mapbox, and TomTom, as well as some open source solutions with OpenStreetMap tiles. For a full breakdown of how each tool measures up and the details of each criterion, please visit Robert Linder's full evaluation at tinyurl.com/wcag-maps. Robert is a member of the Mapser HTML community group, and his contributions have been invaluable. With that out of the way, let's begin. Non-text content. 5 out of 11 tools failed. This criterion states that all non-text content has an equivalent text alternative. None of the map tools offer any meaningful text alternative to the map content by default, so on that front, all of the maps would fail, unless context is provided by the site developer. As mentioned earlier, what this alternative content could look like is a very complicated question that depends on the content of the map and also warrants larger discussion. Because developers and authors may choose to provide additional context, when evaluating this criteria, we are focused on text alternative to controls other than the map itself. In this case, this criterion also applies to things like alternative text for logo images and making sure all icon buttons are labeled descriptively for screen reader users. As an example, maps often use the plus and minus symbol to indicate zooming in and out. As a sighted user, I can see the visual context these buttons are in, and I can also see that the map zooms in and out when I press the buttons. However, if you just hear plus button, the context is a little more unclear. It could mean adding a pin to the map or changing the quantity of another control. We can include context without changing the visual appearance of the control by adding things like alt text to images or an ARIA label to the control. A possible solution to resolve this example might be to add an ARIA label to the button. Info and relationships. 11 out of 11 tools failed. This criterion requires that all information, including a control's state or structure, can be determined programmatically or is otherwise available through text. Tools often fail to label the map structure as a distinct piece of content and as a control. A map generated by these tools is not just a static image, it is a control in and of itself. When the map has focus, most tools will allow you to do things like pan and rotate the map using keyboard shortcuts or your mouse pointer. Thus, the map needs to be labeled so that it is identifiable as a control, not just an image. In tool authors' defense, there isn't a set standard or consensus for how to approach this yet, as map is not yet a valid component rule, so there may be uncertainty on how to appropriately label this map container. The other most common reason for failure is the lack of attention paid to control state. For example, all of these web maps allow users to zoom in and out to an extent. Once you've hit the zoom limit, the appropriate control should be disabled, but very few examples communicate this programmatically, and most only adjust the styles. Furthermore, screen reader users will often have no idea of the current zoom level. Bing stands out amongst the examples, as it announces the current zoom level in addition to the button state, so a user of an audio interface will always know what the current state is. Contrast. 9 out of 11 tools failed. To pass this criterion, all text should pass a minimum contrast ratio of 4.5 for regular sized text. The contrast ratio refers to the contrast between the text color and the background color. Because many widgets do not allow for color customization, having accessible defaults would go a very long way in terms of ensuring map accessibility. This contrast criterion can apply to both the map controls and the actual map content. Some maps had text buttons that did not meet the contrast ratio. Fixing this is as simple as changing the text color on the buttons. Most maps had contrast issues within the map content, particularly with labels for bodies of water and minor roads, such as in this example here. This screenshot shows the ocean filled in with a light blue color, but the text on top of it that says North Atlantic Ocean is a medium blue, and it never gets any darker or larger, no matter how much you zoom in. Maps are in a tricky position, as color hierarchy is very important for establishing focal points, and there is a need to deprioritize certain map features to avoid making the map too noisy. When a map is zoomed out, it is understandable if some minor labels are below the average font size, or have lacking color contrast. However, when a map is zoomed into an area, a good map may have these minor labels take visual priority and be displayed larger and with more contrast. Some maps included a thin white outline around each label to increase the text contrast, a technique that is commonly used in closed captions for TV. Keyboard. 7 out of 11 tools failed. Every functionality that is available to mouse or touch users must also be available for keyboard-only users. This includes all interactable controls, as well as functions activated by pointer gestures, which most maps do have. Most failures in this instance are due to the use of non-native controls. When a semantic element like a HTML button is used, all the behaviors that are expected of the control are handled automatically by the browser. It is very common for developers to add a click handler to a div element and ignore the other required behavior. Some custom buttons are not able to be accessed by hitting the tab key, and cannot be activated because they cannot be accessed at all, whereas others can be focused but do not have any means of activation through the keyboard. A user with a pointer device can pan across the map by dragging the map interface. Some maps lack a way to do this with the keyboard, either because the map container is not focusable or because they lack the keyboard shortcuts necessary. Character key shortcuts. 1 out of 11 tools failed. This criterion states that if a keyboard shortcut is implemented using character keys, then at least one of the following is true. A mechanism is available to turn the shortcut off, or a mechanism is available to remap the shortcut to use modifier keys such as Shift, Control, or Alt, or the keyboard shortcut is only active when that component has focus. This criterion exists to prevent conflicts with assistive technology shortcuts and web interface shortcuts. The NVDA screen reader uses arrow keys to navigate text, and it may conflict with the use of arrow keys to pan and scroll the map. None of the web maps analyzed use techniques 1 or 2. The web maps that have shortcuts and pass this criterion have opted for technique 3, only allowing the keyboard shortcuts when the map container has focus. Focus order. 2 out of 11 tools failed. To pass this criterion, elements must receive focus in an order that matches the content reading order. In English and other left-to-right languages, we have an expectation that elements will be interactable from left to right, top to bottom, in the same order we read text. Here is a diagram which displays the focus order of the Google Maps embed. The numbers indicate which element receives focus in what order. The first focusable element is the map container, which makes sense as the focus order should go from outward to inwards. Next is the Terms of Use button, which is in the bottom right-hand corner. After that comes the View Larger Map button, which is in the opposite corner, in the top left. We return to both zoom control buttons in the bottom right, and finally the unlabeled Toggle Satellite Imagery button in the bottom left corner. In this case, the developers use styles to position the controls arbitrarily. Without proper focus order, the experience of tabbing through the map component is quite jarring and unnecessarily disorienting to bounce from corner to corner. Focus visible. 7 out of 11 tools failed. This criterion is related to the previous one. The focus ring is an indicator which shows which interactive element currently has focus, an example of which is shown here. We can see the zoom out button currently has focus due to the thick black ring that Chrome applies. It is present by default in all browsers, but it is common for developers to remove this indicator without replacing it with their own styles. In combination with the previous criterion, This criterion is serious enough to render a map component unusable for sighted keyboard-only users, because there is no way for them to determine what element is currently selected. In some cases, the focus isn't persistently visible, which is due to the addition of scripts that remove the outline once the element is focused. This criterion is an example of the default behavior being accessible, and the developers have overridden this default behavior to make an ultimately inaccessible design choice. Language of parts. 9 out of 11 tools failed. The requirement to pass this criterion is fairly simple. All it requires is that the content's language is included in the markup. This is important for many accessibility reasons, such as making sure screen readers read words with the correct intonation, and can be useful for features like on-the-fly language translation. Despite the fact this criterion is simple to achieve, many vendors fail to implement this. Passing this criterion is as simple as adding a single lang attribute to the containing element, and lang attributes to text in other languages. The next slide has a GIF which demonstrates an unexpected scrolling appearance. Viewers with vestibular issues may wish to look away for a second. On input, 2 out of 11 tools failed. This criterion states that changing any setting in a user interface component should not trigger any changes of context, unless the user has been warned about it. In layman's terms, if a control is used, there shouldn't be any unexpected side effects like changing the viewport size. Here we have a GIF where the up and down arrow keys are being used to pan the map, but unfortunately, the viewport scrolls up and down as well. Now this can be quite disorienting, so it's important to test for side effects like this. Building accessible web maps is no easy task. The base level of accessibility for existing web map solutions is quite poor overall, and no one widget or library stands out as being far superior to the rest. Criteria where almost every tool fails are often due to the lack of standardization, and this is where having a native HTML map element could really set the bar for what map widgets should strive to be. Regardless, there are a few quick and easy wins to be had. I hope any developers who work with these map libraries can consider implementing some of the low-hanging fruit I've brought up here. Thank you! If you have any questions about the material covered, feel free to reach out to me at nick@nickchan.me.
Whoa. Sorry.
You're with us, Peter?
Okay, yeah, we're back. That was very interesting. Thank you very much, Nick. Really excellent presentation, and with all kinds of little short lessons, short and digestible lessons that we can go back to as need be. So with that, I guess I'd like to hand it over to Brandon. Are you ready for the stage?
Yeah, can you hear me?
We can, yeah.
Awesome. All right, let me share my screen here. All right. You might hear my screen reader here for a sec. Okay. Are you guys able to see my screen?
No. Not right now.
All right.
We can see it now.
Perfect. Awesome. Cool. So yeah, this basically is going to be an extremely rapid introduction to non-visual maps. It's going to be really, really brief because there's a lot more to cover in two modalities than there is typically in, like, if this was an introduction to visual maps alone, because audio and tactile are kind of big. But anyway, so we'll go through this really briefly here. So this is what most web maps are today. Basically, it's what we saw in the last presentation. Basically, I'm looking at particular widgets. So the ones that are like embedded into a website and can show like they're typically a canvas that that you use to pan around. You can see the vectors or the raster data presented in a canvas. So there's some problems with these, not least of which are that 285 million people in the world can't utilize those maps, and they're not non-visual. And currently, the WCAG guidelines say that you can use a text description. But there's a huge problem with text descriptions in that the whole fields of cartography and data visualization arose because text descriptions were not adequate enough. And so if we think that text descriptions are adequate, then we don't really need data visualization or cartographers. So that's just, you know, I don't think that text descriptions can convey the spatial information. There's a lot of studies that show that text descriptions are not do not provide the same information as an actual map. So I'm going to look at two different types of maps: tactile maps and auditory maps. And each one of these has very similar requirements. So one of them is that each map needs to have a name attribute. So when you're in one of these other modalities, they're more egocentric. So basically, you're moving like your finger through the map, or you're moving your head through the map, like as a listener, and you're not necessarily viewing the map in totality like you would in an allocentric point of view, like you would using like the map that we saw at the beginning of the presentation. So if you have an unmarked polygon, point, or line, that's basically not extremely useful because it doesn't provide any kind of context of why that exists. There's also yeah, so that's basically, those are the commonalities between these different types. So the first type of non-visual map we'll look at are Vibro-auditory maps. And these are presented on a tablet, and you move your finger around the screen, and when you reach a line or a polygon or a point, it'll vibrate. And when there's intersections, like say, for example, like there's two lines intersect, there'll be like a pulse, and then it will tell you what the name of that intersection is, what the two lines are, the names of the two lines are that intersect, and then you can go and move your finger along the intersecting, you know, if you want to keep going, or along the intersecting line. And this uses the audio vibration API. Sorry, the web vibration API. I don't think it's actually been incorporated in the web, but the web vibration API, I think, is probably adequate enough to do this. Here's some citations for the Vibro audio maps, and you can read more about them and watch some videos and try them out. So the next section is on digital auditory maps, and this is actually my specialty, so I'm probably going to talk a little bit more about these than I am on the Vibro audio maps. So the digital auditory maps, basically, they use as I said before, an egocentric point of view. So basically, use your arrow keys or some sort of control mechanism to move your listener through the space. And they use something called binaural audio. And binaural audio is where the sounds, the features in the map have different sounds, and you can hear those sounds around you in spatial audio. And a lot of features also will have their own sound. So when you're moving over a feature, that'll make a sound. Here's an example of a city map using that's in taking OpenStreetMap data, and it's a they call it the team system, and basically this is what it's like. This is the team audio maps system, and we are currently in London on Gabriel's Wharf, facing south. And I'm going to do a scan to see what's around us.
Sonar dialog, press tab to navigate. 4 landmarks. Restaurant 32 meters 2 o'clock. Burney Spain Gardens 14 meters 8 o'clock. Burney Spain Gardens 54 meters 10 o'clock. Restaurant Studio 6 16 meters 12 o'clock.
So we saw that there's a garden which we can hear at 8 o'clock in our left ear. And there's a restaurant in front of us at 12 o'clock, which we can hear through the clean conditions. I'm going to walk towards the restaurant.
Restaurant Studio 6 on Gabriel's Wharf. Heading south.
So this basically takes the type that's in OpenStreetMap, like restaurant or park, and assigns a looping sound to it that you can hear in spatial audio. And then it also uses the name attribute, as you saw, to label what exactly you're in when you reach the polygon that's like the restaurant. Right. Here is the references for the city map that we just saw, and you can go and view those papers if you want, or try the team system yourself. It's pretty interesting. So the next type of map we're going to look at are heat maps, and you're probably pretty familiar with these. They're basically they show different points, data points throughout the map, and how they change throughout the geography of the map. Should I play this?
Intersound is an interactive sonification tool that allows vision-impaired users to explore map data, such as population densities. We are looking at a U.S. state map of population. The population for each state is presented by a violin sound. A high pitch means high value, so California has more people than Alaska. The sound is in stereo, so the sound for Alaska comes from left, and the sound for Maine from the right. Pressing the space key reads all the details about a state.
Basically, that's kind of a really brief overview of the heat maps, and you can go test these out. There we go. Heatmap References. There you go. You can go try this out as well. It's called iSonic, and it's very interesting. And also I didn't mention this here, but the SAS Graphics Accelerator also has a is an audio heat map, has an audio heat map as well. And so yeah, that's basically it's a pretty I would say it's probably one of the more standard types of auditory maps nowadays. So this is an enclosed space map. It's very similar to the first map, where you have a yourself as a listener in the space, and there's different sounds throughout around you. But this one has a little more. You can hear a little more sounds in this.
First person view.
Long ramp. Ava's bridge. Ground carousel.
25:18.
Disc spinner.
Playground walkway.
Net spinner.
Laser harp is very far off, ahead and to the right. The nearest point is at 28:46.
Laser harp.
Grid view. Playground walkway 22:49. Laser harp 22:48. Playground net spinner 22:30. Net spinner.
So that's basically So that's basically another version of an enclosed space map. So that'd be like a building or a playground. This one's a playground, or something like Disneyland, which is a little bit different than a city map or a heat map. These are some references for using this map, and we'll actually try this after this presentation because I'm actually the one who made that, and so you heard my voice in there. So basically, these are the maps that non-visual users have created for themselves, or have had a lot of research done on them. And if you have any questions about non-visual maps of any type, please get in contact with me. My email is brandon.biggs@xrnavigation.io, brandon.biggs@xrnavigation.io. And I would like to acknowledge the following funding sources of NIH and NIDLR. Thank you, and hope you stick around for the workshop.
I assure you, Brandon, we will. That's a pretty interesting talk. And so I think you're up again.
All right. Let me, did that unshare my screen? No. Can you guys see my screen?
Yeah, it's still there.
Okay, one sec. I lost Zoom.
Oh.
I've got too many tabs open. Okay. So let me put it up here real quick. All right. So if you go to your the website URL here, xrnavigation.io/AUDIOM. Yeah, AUDIOM-GETTING-STAR. There you go. Audiom, xrnavigation.io/audiom-getting-started. You can go through this kind of at your own pace. Basically, what you need to do is log in to the Audiom website. And I must preface this by, this is kind of a new system, so there's not a lot of polish on it yet. So we're in the midst of building it out, and you should, if you want to keep exploring this after today, there'll be a lot of updates in the next couple of weeks because they're really starting to work on it now. So anyways, basically
Brandon,
what Audiom is, yep.
Hey, Brandon, sorry, this is Doug. I just want to make sure that people that we're setting the context. So that was the end of the presentations, the earlier presentations. We're now entering into the breakout, which is building cross-sensory maps using Audiom. And so, and Brandon is also is the facilitator for this. So I just wanted to make sure people understood that the presentations have ended, and now we're actually in a breakout session.
Yeah, good point. Thank you. Sorry, Doug.
No problem. Just making sure people understood.
Awesome. But you should definitely stick around. So, so Audiom is a tool that allows you to make maps that have an audio component and a visual component with the same data set. And currently they run off of GeoJSON. But I'm adding other other map types as I get to it. But let me know if you want me to add a particular map type, and I can a data type, and I can add that. So I guess one major con of this is that raster maps aren't accessible by default, just because they're a bunch of pictures and they don't have any information that can tell the computer what exactly is happening, and thus can't tell the user what's happening who's using the computer. And so so it can just tell you kind of what colors are at a particular location. So anyways, vector maps are really the only way to make accessible maps using this method. First, you go to audiom.xrnavigation.io and sign up, and then you will enter into you'll enter here, and you can read a lot about Audiom here. Make sure I got the latest version. Anyways, so basically, the first step is to go to data sources, and here click the add, the create new button, and that's going to bring you to a form here, so you can enter a name. So I'm just going to call this box. All right, here's where you can write your GeoJSON. So I like to use, I have people use geojson.io, and I link to it in the guide. It's actually not accessible for blind people, and I'm in the midst of also building a map editor using the same technology for blind people, but it's not quite ready yet. So I actually wrote out some GeoJSON by hand. And go ahead and select that. So you want a feature collection because that's the best. So I'm going to go ahead and paste that here. And then I'm going to click the create button. And that created the data source. So now I'm going to go click on maps. And there are some existing maps here. The playground map is there if you want to try it. It's called Playground. Or we can go create a new map. And this is box 1 map. And then I'm going to leave these other fields blank. And then we'll do box 1 as our data source. And then hit create. And
blank space 1, 2.
Now we can go explore this. And so what this did,
scurry building 3, scurry building 4, 2.
So we can hear that the box in there was called Scary Building. And I'm going to switch to using my screen reader because I really don't like that that voice. But basically, now you can go through and explore the map that was there. And you can see that there's all the different information about the geometries there, which is really cool. And there's the visual view down below. I don't know if you guys can see it. I can't see it, but I know it's there. And I think there should be some sort of thing that, like a green dot, that that shows where your character is at, your listener is at on the audio map. So, anyways, that's basically how you you create the audio maps in Audiom, and you can add sounds to your different objects by adding different attributes like short underscore sound, or it's all in the guides if you want to learn how to make these. Or you can contact me and we can talk about making some of your data sources accessible in Audiom. So another cool thing here is you can copy and paste this embed URL into your own website and Audiom will be there. Right now, there's kind of a limited number of shares. I think it's like 1,000 or something like that. So if you want more, contact me. Yeah.
Because I see that you can embed the iframe. Does it have the possibility of like showing the location? Like imagine that I want to create for a park, and the user will need to ask for the geolocation so we can pinpoint him. Is that possible currently, or it will be, or can be done, or is not a use case?
So let me understand your question. So basically, you're saying that you want to have your a park directions from your current location to a park.
Or or let's say that I will take a group of 10 people that I have problem with sight, and I will bring them to that park. They will each have an app that will be loaded and to track their location where they are now. So kind of the point to update based on the location.
Yeah, so that's not currently available, but that's definitely something that that we're going to be adding pretty soon. Because I believe I've never actually done it yet, but I'm pretty sure the web API, there's a web API to get your current location. So
yeah,
that's definitely I got some funding to build that app, so it's definitely in the short list of features that we're going to be making. Yeah. Awesome. So yeah, let me know if you have any questions, and please feel free to make as many maps as you want and share them with your friends. And yeah, that's basically Audiom.
Thank you very much, Brandon. That's pretty cool. I've already started tinkering with it. I'll be sure and get in touch. So do you want us to play with it now and give you some questions and whatnot?
Sure, absolutely. Yep. Sorry, I'm trying to find Zoom. One sec. Let me find Zoom real quick. I want to be able to see my Zoom. Okay. All right. Now, now you should be able to see me and not my screen. Sorry, actually.
I get an unexpected error as a code when I'm trying to access the ID for public map.
Yeah, sorry, that's a bug. Don't do those for those two maps do have an error. Sorry.
Four, I see they have like the playground also. No, the playground works. The demo also. The 8 ID.
Yes.
Okay.
Sorry, the 8 ID is the one that I just made. No.
Scroll demo.
I think we're seeing yeah, we're seeing everybody's maps that everybody's been making. So those are being shared here. So everybody can see them at the moment during this presentation. So yeah. So somebody created that, and if it's giving an error, that means that that the data isn't formatted correctly.
Brandon,
yep.
FYI, I just want to make sure you know you're still sharing your screen.
Yeah, that's fine.
Okay.
I can't find Zoom to stop.
Okay.
Would you prefer to stop? Because Coast can cut you out.
Okay, it's up to you guys. I'm not. Yeah, so data sources, search data sources is where you look for the name of the source that you are you want to add to your map. So basically, if you added a data source, then you type in the name, and it should auto-populate, and then you click create map, and that's Hi, that's what that.
And another suggestion would be, because probably most of the people that will create the maps will be people that they will be able to see. So maybe to have the ability to add like a to have like a tile layer behind. So for in my use case, I would want to like see, okay, the points are really where they should be based on a rendered map, or like OSM, or like Bing images or something.
Yeah, I guess the issue with that, I want to see if there's some sort of detailed vector layer that we can hook into, because the tile maps, I mean, like it completely defeats the purpose of the map if you start using raster data, because
I'm thinking just when designing, like when you will put
yeah.
it on the website, maybe not, or in the yeah, but at least for the designing part.
Yeah, that's definitely a good point. Yeah, I can definitely look into that. Right now, if you create it on geojson.io, I know they definitely have a raster background. I haven't built a map editor yet, so yeah, I'll definitely look into that, and hopefully there's a better solution than just like not using raster data, because I would like to figure out, you know, a good alternative to raster data.
Can I ask you a technical question?
Sure. You're a little bit quiet.
Yeah, sorry, I had
yeah.
the microphone away from my face. I got it. Where do you I assume you have to save some of that data somehow, whether you're doing it in cache or an actual file somewhere. So I'm just kind of curious how you save that map data and that GeoJSON data.
Yeah, so currently it's just a blob in a SQL database. Does that answer your question? Each data source is its own blob in a SQL
Gotcha.
database.
So you're doing like you do your SQL query, and then on its way out, you just do sort of like just parsing, you know, right in between in a shim to make sure it comes out as JSON.
So when you load a map, it's parsing the GeoJSON data in real time.
Gotcha. Thank you. That does answer my question.
I'm sorry, I'm going to hit you with the next one that might put a little more pressure on you. Have you thought about a non-SQL solution in the background? Yeah, I've thought about it. If you have any good suggestions, let me know. Because one of the issues that that we kept running into was you know, being able to separate out different data sources. So if like a lot of different people wanted to have you know, different data sources, is there like an easy way to do that without making like a ton of different tables in the database, and or how to do that scalably? So this is definitely not, I'm not a big expert in geo databases. So yeah, any suggestions would definitely help.
Cool. Yeah, I mean, I think it's a whole, maybe another conversation we don't have to have right here, but yeah, I think I would definitely have a couple ideas.
Awesome. Yeah, please get in contact with me. Sure. I'd love to talk to you more about that because it's a big issue.
Yep, I feel you.
Brandon, can I ask you a more higher level question? Not specifically about Audiom, but about audio maps.
Mm-hmm.
What is like a reasonable amount of detail? Because with a visual map, you can fill in lots of space and use other cues to emphasize what's important or not. But with these explorable audio maps, are you able to really filter through extra detail, or is it best to keep it stripped down?
No, you can definitely filter through a lot of detail. Now, I haven't. Typically, you look at it like a viewport, and so you do filter out the data in this particular chunk and explore that particular chunk, and so say for example, you're looking for one particular point, you would use probably a list view rather than like this particular grid view. So there's 3 different modes that you can navigate this map in. There's a grid view where basically that's the default, and that's as you're moving through, you can hear the coordinates, and you can hear the like the polygons that you're over. And then there's another one that's more first person, and you can navigate around like you're in a real environment. And then another one where you basically can view a menu of all the different options. And so you can definitely do a lot of detail. You can view as much detail as you want, just as long as you can zoom in and out as much as you want. And you can view it granular, very very granularly. Or you can go zoom out and see it in a more overview. You might miss some small features, like say for example, there's you want to view things at a kilometer level, and there's some meter stuff. You won't be able to notice those meter stuff unless you turn on some sort of setting. But you can go into a menu and see all the different items there, and if you know what you're looking for, you want to really quickly move through that list, you can like press the down arrow and hear the different objects in the list very very quickly. But this is definitely some big maps are not are something I need to continue exploring.
Interesting. So an Audiom does that sort of level of detail scaling out automatically, or does that have to be designed in?
I mean, so basically, you can zoom in and out, yes, with Audiom, and I wouldn't right now. It's built. It's this particular at this particular time. It's particularly put for meters, and so when you put in a GeoJSON object, you're moving by meters when in the map, and so there's some parsing of the coordinates that's done, and you're put into a sensible plane, because you don't want to be hearing coordinates spoken out every time you move to a different square, because that's just a little bit nuts. And so so it does turn it into meters, and but definitely it's not hard to turn it into kilometers. I'm just trying to figure out a good user-friendly way of doing that for the map creators.
Brandon,
Mm-hmm.
This is Doug. Are you expecting people to upload their own soundscapes? What do you call a particular sound icon for, like that looping audio that you're running for, say, a playground? Or
yeah, sound packs. So that's basically what I call them.
Sorry, so, I didn't understand what you said.
Sound packs.
Sound packs.
Yeah.
Okay. Are you expecting people to upload their own sound packs, or are you going to make sound packs available by default?
Both.
Okay.
So there's already one in there by default. Unfortunately, the current update on production build doesn't show it. But yeah, so there definitely is a default. It should be there tomorrow. But and you should be able to just go, click and listen to the different sounds. So there is going to be one by default, and I'm going to continue building on it as time goes on. And hopefully, I should have different sound packs that you can use by default, or you can eventually you should be able to upload your own and use those in your maps. So like the playground, for example, uses a custom sound pack, and if I wanted to use the sound pack for the map that I just made, I could do that.
So it seems to me, it seems to me that having familiar sound packs, or having a familiar sound icon, I'll use, or soundscape icon for similar, or like for restaurants, having the same thing seems like a useful orientation tool.
Yeah, it absolutely would be.
have you done any studies to see the extent to which I mean, obviously, when you're walking around in the real world, right, you're hearing, it's not every restaurant sounds alike, right? But you can identify them as restaurant, right?
Yeah. Mm-hmm.
But it seems that in a constrained environment like this, that it might be useful to have the same sound icon being used. And I wonder if you've done any studies that show one way or the other whether that's the case.
Not really. The best thing I can think of is that the team system that you saw earlier in my presentation was did have a specific sound set of sounds for different types of locations. So like a bar was a particular sound, and a restaurant was a particular sound that looped. But as for like a standardized sound, no, there's no standard auditory icons for these, and I don't think there's been any studies to determine what people would recognize most naturally as like a restaurant or a street, for example. But one thing that you can depend on probably is that, and there's been some studies on this particular fact, is that you do have an analogical connection to the world. So if you hear like a sound of wood, like wood sound, like that's a sound of wood, and there's no other sound that could be. It's like, you know, when you see a giraffe, that's a giraffe. There's no other thing it could really be. Or, you know, if there's connections to the real world that you can kind of depend on, and so that definitely helps with creating these maps. So you can use these real world sounds in your maps, and that makes it much more relatable, so that people don't necessarily need to use a lot of cognitive processing to understand what you're trying to convey.
I think I understand what you're saying. I think that sounds right to me, but I also know that Foley artists create sounds that are nothing like the real world sound, but for some reason they strike people as being the right sound. For example, hawks don't sound like you hear hawks in the movies, right?
Yeah.
They sound very different, but that is the standard sound for hawk. So Foley artists and sound effects people use the sound for hawk for hawks, but that's not what hawks sound like.
Yeah.
They exaggerate sounds in order to emphasize key characteristics, like the clop clop of the horse, right?
Yep.
Yeah. I see actually that Amelia is pointing out a Zoom issue. We can talk about this offline. It's just I'd like to understand better what that relationship with the sound icons is.
Yeah, absolutely.
So Amelia has a question. How do I get the gallery view? Zoom issue. How do I get back to gallery view? That's
sorry. Not for Brandon. That's for anybody who knows Zoom better than I do. Sorry for interrupting.
I apologize. No, you're not interrupting. I was dominating the conversation with Brandon.
I think in the top right corner, you have the view, and you can select between gallery, speaker, or full screen.
Yes, it's come back on now that Peter has his video. I guess if nobody has video on, it doesn't even bother showing the speaker names. Anyways, sorry for the distraction.
So
do we have any other questions for Brandon? People who are maybe playing around with the examples?
I wanted to ask him, and I put the link in the other chat, if he knows TagInfo, which is a website that shows all of the most used key value pairs in OSM. So we can find like top 10 or top 500 if you want. The most used like amenities or location. So you would identify, because this will be the most that you will find in OSM. So it would be useful to create for them.
Yeah, that's good. That's good to know. So one thing we're going to be doing really soon is actually hook up, very similar to how Team did. We're going to hook up the whole entire Audiom system to OpenStreetMap. So all the data in OpenStreetMap should be available if it's got the correct labels in it. And I'll be trying to parse those out and see exactly what it is. But that's something in our short list. We have a project that we're doing that right now. So.
Okay, and if you have problem with like loading the planet and things like that, tell me. I have somebody that they already loading the planet and processing it for vector tiles and raster tiles, and I could connect you.
Oh, that'd be great. Yeah, it's not something I've investigated too heavily. Going and doing queries on OpenStreetMap. It's not
Yeah, and
something I've
also
done.
like the planet is huge. It's like the extracted
Yeah.
XML is like 600 gigabytes or more.
Yeah, yeah. So there's a good way to go in and grab little chunks of that. Yeah, let me know, because that's definitely something I'm gonna have to deal with.
Yeah, and probably you will need like a Postgres server if you don't have to store the data, because Postgres is kind of the best, because you also have like the PostGIS with like the GIS extension.
Yeah.
And it's fit really good, and there are some tools for automatically loading to Postgres and other things like that. But
Yeah. Yep. Yeah, that's definitely something I'll need to investigate. And I'll probably end up creating my own. I know another company that uses OpenStreetMap, and they made their own server for OpenStreetMap, and I'm definitely probably gonna have to do that.
yeah.
Brian Haverberger has a question on Gitter. I'll read it out. I have a question on granularity. Do you see this being granular enough to help someone get around their favorite baseball, soccer, football stadium? Like,
Yes.
could it help you get to the vendor you want or the bathrooms nearby?
Absolutely. Yeah, absolutely. I've done it for a lot of conferences. Made these maps for several different conferences and indoor spaces. So that playground map that you saw, it can definitely help you get from the bridge to the slide mound, or the bridge to the stepping sounds. It's not hard to do. So yeah, absolutely. And especially if you get more detail in there, like put in walls and stuff like that, then you can tell people where to walk and where not to walk. And yeah, absolutely.
And also, I don't know, do you know Overpass Turbo?
I'm not a big expert on OpenStreetMap, but not really, no.
Okay, Overpass Turbo is a service where you can do like queries. You can write a query filter, and you can select like, okay, give me just this and this and this. So, and so what you could do is like the user, you get the location of the user, and you have like the bounding box of an area. It could be like,
Oh yes, yeah.
And it can download it, it can export directly to, you can have it like JSON exported. So this could kind of help you to not create the whole planet and kind of each client to do it in the browser, the downloading, and then you just have some JavaScript that will process and do.
Yeah, I think that's probably what we're gonna do initially. Is use that Overpass Turbo. Yes, I do know Overpass. I didn't know there was one with Turbo, but
this is for like visual. So instead of doing everything like this will kind of show you on the map, and you can also style it and other things like that. It's more user friendly.
I see. Okay.
Could you?
Yeah.
Sorry. What is Overpass and Overpass Turbo?
For OpenStreetMap.
Okay.
Overpass is the API that you can use to access and download parts of of OSM data. Overpass Turbo is kind of a wraparound Overpass that allows you to create more friendly queries to query the database, and instead of showing the data like the JSON response, you see like visually in a leaflet map. I think you see visually the points that it is returning.
Okay, thank you.
won't help me till it gets into an audio map, but yeah, I'll definitely look into that.
So to go back to the question of, is this useful for navigating in places, at this point, are you working only on something that people can explore ahead of time? Or are you connecting this up to something that could be live on their mobile device as they're actually in a place?
Yeah, so there's a couple issues there. First is we need to build a mobile interface for this. Right now, if you have a keyboard, you can use a keyboard on your mobile device, but a lot of people don't usually bring that with them. So we have to build a touchscreen interface for this, and that's on our list of stuff to do. And then once that's built, then yes, we're looking into getting positioning. But typically, this is a pre-trip planning for the next several months. This will be just primarily used as a pre-trip planning tool,
And
or
yeah, continue.
or any other thing where you would use a map for that's not necessarily the "you are here" dot on the Google Maps or whatever as you're walking. So that's the only pretty much the only major feature at the moment that you can't really do with this yet. And so but yeah, it's definitely on our list of things to do.
Yeah, definitely. I mean, we have a couple talks of this the next session. So Sunday night, Monday morning, we have talks on one specifically on maps of indoor spaces, and the others ones are also talking about wayfinding and maps for in-person accessibility. So it definitely all flows together.
Yeah, absolutely.
I wanted to add that in OSM you have close to 1 million locations that also contain information if that place is accessible for persons with wheelchair. I'm thinking that some of the users that will use this, maybe they are also in wheelchair, so that would be useful for them to kind of, maybe they could know like, okay, this is accessible or not. And also there is like opening hour for around, I think, 500,000 also points. But
yeah, absolutely. I think one of the things I'm gonna try to do eventually is when you hover over the box or whatever with your mouse on the visual view, it'll give you you can explore the properties, and you can see if it has if it's accessible or not, and then same with the audio view. You should be able to see these different properties and see if it's accessible, and you should be able to filter by items that are accessible or not. But unfortunately, it's not all the items, but 1 million is a really good number. And typically, you're probably not going to get a lot of really terrible sidewalks if it's accessible to wheelchair users, which is nice for almost everybody. So.
And in OSM also for the roads, I think there is tags to say that if there is like a sidewalk on the left or on the right. Not that many people use it in Germany. They usually use it, but yeah, this is something to consider.
Yeah, that's really important. Yeah. OSM, I don't even think gives the level of detail that a blind person would really like to have. A lot of people, when I've done studies, like they say the most the features they want most are parked cars, the planters, the doors, like where exactly the door is in the building, and like poles and bushes, which aren't typically used, and also the side of the side of the street that you're on,
and trees,
so,
probably.
Yeah, trees. Yeah. So anyways, yeah, that's like we were asking about detail before. Like that's kind of the level of detail that that blind people really want in a map. And so yeah, you can get down to that level, and that's really the level that that people like.
Couple more questions in the chat. Maybe I'll read out the first.
Thank you.
Audio 3D an audio 3D preview of the venue you want to go to get your bearings ahead of time. Will it be able to support 3D sound packs? Not sure if that is a whole new file type or something.
No, so how it works is we use the WebAudio API, and in the WebAudio API, you use the sounds are put into a particular coordinate in space, and then you're the listener and you move around those coordinates, and as you move, the sound changes its position relative to you. And so like you hear in the playground map, and so all you really need is a looping sound, and that gives you the 3D audio that you need for I guess for any type of map. So I'm not sure that's exactly what you were asking, but it's really just any type of sound that you can put into this map.
So just to clarify, that your system takes care of the positioning.
Yes.
They just have to, it's already doing 3D positioning.
Yes.
And they just put in the sound that is going to be positioned.
Exactly. You just attach it to your feature.
Right. There may be a follow-up question, which is, can you design, is there any other way of designing your own 3D features? Or is this taking care of, like, I don't know what that would be. I'm just speculating that for some reason somebody might want to, for example, have a level of detail. So it's not just the, positioning, but it could be how loud or faint something is, or how much detail you hear from a particular restaurant. Like if you go to, if you start off, you might hear chatter, just like voices. And as you get closer, you might hear, for example, the clinking of silverware and glasses and plates.
Yeah, so at the moment, those that type of event is not there yet, but that's definitely something I want to add. And probably won't be for a while because I want to try and get OpenStreetMap and all that kind of other stuff added in first. But definitely that level of detail is something I want to add eventually. And so you could basically build your own virtual reality spaces using this map and do all kinds of granular support. It definitely has that capability, but it's not there yet. So
Okay.
yeah, we just use the automatic positioning now.
Okay, cool. Thank you.
And there's another comment that says, I wonder if in the future, if this could link with sensor data to provide live navigation based on real conditions. For example, if I'm walking and a sensor knows there's ice or a snowbank in front of me, I could be directed away from a hazard.
Yeah. So sensors, I don't know very many that actually work for that kind of level of detail. What we are looking at is there's Smith Cadwell and several other companies are building indoor wayfinding apps that are basically use computer vision and inertial odometry to position yourself in the indoor space. And so we're going to be hooking up Audiom to that, and that should be able to kind of act as your green dot as you're moving through the building, and you should be able to use both the Audiom features and the features of the wayfinding app to tell what's around you. But for sensor data, yeah, that's not, I guess the closest could be maybe like real-time information through satellites or something like that that you can get through an API. But yeah, I don't know if very many sensors are reliable enough to give you enough information other than a cane.
So one other question, since you have a lot of web map developers on the line, is there, like, is Audiom open source? Are you soliciting contributions, or?
Yeah, so currently it's not open source. It's a kind of a prototype commercial product at the moment. And so if you want to continue developing, or see continuous development on it, or use it in your project, just contact me and we can talk about it.
So I have one more sort of peripheral kind of comment here. Yesterday there was a presentation on GeoJSON-T, which was taking GeoJSON and adding time to it. Have you ever thought about an actual GeoJSON extension to attach audio?
So I kind of have built my own GeoJSON format. If you look through the guide on attaching audio, I've kind of built in my own property set, and that's what I use for determining the sounds. So once it gets a little more standard, then maybe we can think about adding an official quote unquote audio or cross sensory feature set and property set. I don't know exactly. I didn't see that presentation yesterday. What exactly they did.
Yeah, it's fair. I mean, it's simple. Instead of writing into properties, he just proposed a new properties thing called when, and then the data goes in there. And that's
okay.
It would extend a object style thing. Yeah.
Okay. Yeah, that makes sense. I guess the closest thing I did was for a custom. If you have a custom, you're not using the geography. So, for example, the playground doesn't use coordinates. Like the flat long coordinates, I have a custom thing that you put in, that you use a custom coordinate system, and that's then it just uses your coordinate system. So that's the closest thing I've got to it. But hopefully once more maps are created, probably in a couple years, we should have enough standardization for creating an official set of GeoJSON.
Yeah, because I know, again, just and my bias is humanities, because that's what I work in. There's just a lot of interest around attaching sound in space. It's just, it's really for the, like I keep saying, like the poetry and the music studies kinds of people that are looking for that. And
yeah,
I hadn't ever really seen a real extension that connected sound and space as one kind of, wrapped up standard.
Yeah. Yeah, I think it'd be very interesting.
I think you're working on something pretty unique, and it's interesting. I just had wondered if you thought about that yet.
Yeah, no, I've definitely thought about like how we represent buildings in GeoJSON, and how we represent campuses and other spaces, and multiple layers, and how you show relationships. But I just kind of added in properties for the audio. I didn't really think too much about it.
Well, to be fair, that's what everybody else is doing too. That's why we have these kinds of workshops.
Yeah, absolutely. But I hope like the name attribute, like that's one thing that's really important, because as you can tell, like when you're moving through the grid, it tells you a name every single time you move through the space. And if you don't have a name, it's just going to say, blank polygon. And you got a lot of those.
Yeah, and if you only have the English name, then you make the rest of the world mad, so the internationalization will become a part of that, and all of a sudden your ability to just use a string disappears.
Yeah, if you have a good method for doing internationalization with GeoJSON and names, let me know. But typically names are actually pretty darn universal, unless you get with country names. So so I don't think it's that big of an issue, but yeah, it's definitely something to think about, especially for countries and states.
If there are other questions, please feel free to ask them, but I think we're officially taking a 10-minute break before the start of the next session. But everyone should, in 10 minutes, we'll be starting the next session, which is the map and layer speculative polyfill, and that's being facilitated for MapML, and that's being facilitated by Peter Rushforth.
Awesome. Thank you, everybody.
Thank you,
And,
Brandon. Very, very interesting and fascinating subject, and looks like it's going to be an awesome product.
Awesome. Yeah, and get in contact with me. There's the contact form up here and the feedback button. You can contact me.
I look forward to talking to you more offline about this.
Yep, absolutely. All right, can you stop my screen share now?
Oh, your screen has been stopped shared. Sorry.
Oh, perfect. Awesome. Cool. So now you're not hearing my screen reader. Awesome. Thank you.
Great.
Okay, we'll reconvene with the channel open for 8 minutes, and then we'll reconvene. Well, actually, I could be a bit more ready, but I apologize if it's got some rough edges, but I'm trying to explain part 2 of the MapML proposal that I introduced last night or yesterday. And so here we go. I will share my screen. Good evening and good morning. In this presentation, I'll give part 2 of an overview of the MapML proposal. In part 1, I explained why it is that I and others in our community believe we need maps to be understood natively by the browser. This is not uncontroversial, and the presentations that preceded and followed my own outlined some of the challenges that lie ahead. I then described the function of the proposed map, layer, and extent elements. I concluded by explaining the concept of tiled coordinate reference system, which is our attempt to consolidate the terms and concepts behind spatial coordinate reference systems in order to make them implementable by the browser. In part 2, I'll talk about the details of many important parts of the MapML proposal as defined as far as I understand them. Your help is solicited to clarify or better define these things so that they can become implementable if they aren't already. All right. A location in MapML. I just sit back and let it happen. A location in MapML is a general term for anything that can be characterized by coordinates and a zoom value. This concept could include simple feature geometries eventually. In extent processing as conceived so far, a location is an event associated to the extent that is fired as the browser requires new content to paint. This can be a single tile with its 4 sides and corners. Repeated such events will eventually cover the extent, or it can be a rectangle, the size and position of which is calculated at runtime by the rendering engine such that the rectangle covers the entire extent. As described yesterday, during extent processing, location inputs are used to refer to and declaratively access location event properties, specifically the individual axis values of the event's location, as well as positions that are relative to the shape of the event. Also, as described yesterday, the extent itself is bound to the viewport of the map, and the whole extent can be treated as a location event for some purposes, specifically when requesting content from services like WMS. The link rel to which the input is bound by template variable reference dictates the nature of the event that is generated. For example, the link rel equals image will generate a location event for a rectangle that covers the extent, which is useful for WMS, while a link rel equals tile will generate enough repeated tile coordinate events as tiles are required to cover the extent. Tile and image location events have sides and corners which can be referred to by the enumerated position attribute. Associated to the link rel equals image element in the above example, we see two additional inputs with type equals width and type equals height, respectively. These new input types are required by the current proposal because I could not think of another reasonable way to declaratively request the result of a calculation in the location input, such as might be expressed as width equals top right minus top left, for example, which would obviously yield the width of the required image. So we propose to create the width and height inputs in order to declaratively access these properties of the image event rectangle that encloses the extent. Your advice is requested. In the above examples, we're using input type equals location to serialize the parts, that is, the scalar property values, not the whole composite object, of tile event coordinates, which have a regular location and geometry, as well as corners of map extents, which are dynamic but known at runtime, which are pixel-based but have variable width and height. In the future, we anticipate that it may be possible to rotate the map, in which case the calculation of the image or the set of tiles that covers the extent will be slightly more complicated for the browser engine, but not for the author. The above should still work, we believe. The coordinates of a location may be expressed in any of the coordinate systems associated with a given TCRS, although sometimes such expressions don't make sense. For example, trying to describe a map extent with tile rows and columns may be slightly inaccurate. We think locations should always have a zoom level associated to them, which is to say coordinates on a map should always have a scale. It might be possible to eliminate the input type equals zoom proposal if we define zoom as an axis of the coordinate systems. Then we would be able to serialize the zoom axis of a location event with an input type equals location. The location units attribute identifies by acronym the coordinate system that the location event will take place in. For example, units equals tile matrix identifies that a location event at a tile in a tile matrix is being serialized. The location axis attribute is used to identify the scalar axis value that should be returned. The location axis attribute can refer to any axis of any associated coordinate system for the event. This doesn't seem too useful for a tile event where what you want to receive is the row or column axis. So why would you want to ask for easting of a tile event? The value of being able to request the serialization of the location event of any axis becomes clearer when you need to use the projected or geographic coordinates of a corner of the event. You can do so by specifying the corner location you want using the position attribute with a value such as top left, bottom right, etc. In this example, I'm showing the use of tile events to access an actual WMS, which is very useful for WMS layers that don't have labels or polygon lines that can be visually disrupted by tile boundaries. Note that while location units attribute refers to the tile matrix coordinate system, and the link rel equals tile will generate a tile event, the corners of the tile are being serialized in Web Mercator projected coordinate reference system units, or PCRS meters, because we have requested the relative position with the position attribute and the PCRS coordinate for that position with the axis equals easting value. So far, we've not described how the browser can avoid asking for tiles or content that don't exist. The first means is by specifying the min and max attributes on individual inputs associated to a link template. The extent within which a link URL template should request content from the server is determined by the min and max attributes of associated input type equals location and zoom variable references. If such limits are not provided or not understood on a per template basis, the client will look for extent scope values as provided as meta elements that I'll talk about in a minute. If such values aren't provided or understood, the client will use the limits defined for the TCRS as a whole. I mentioned that we can provide semi-custom extents for MapML documents by specifying the extent in a meta element according to the proposed syntax shown. Likewise, we can specify default document properties of MapML content, such as projection, zoom, and coordinate system. Domain sharding is a technique that tile caches, such as OpenStreetMap, use to work around per-domain connection limits established by browsers in order to improve rendering performance. In this instance, we've set up a hidden type input with this map-specific shard keyword, indicating that the browser should distribute the requests made against the linked cache in round-robin fashion using the values from the associated data list. Select inputs in the extent scope may be used to solicit input of variables from the user. These selects could be displayed in a standard location, for example in the layer control. The value of the select made by the user, for example the date parameter shown here, could be used to allow the map to query and display dimensional data such as web map service dimensions. HTML uses undifferentiated opaque URLs in various ways for different reasons, which are reflected in a few elements. The link href element, the image source attribute, and the href form all represent different markup and reasons for associating documents. First, to help keep separate concerns separate, there's the link element, which is used to associate one file with another in various relationships, such as style sheet or JavaScript inclusion. Next, the source attribute is used to imply a composition relation between the source document and the linked resource. Finally, a href markup is defined to be a hyperlink and serves as the glue for the federated nature of the web itself. The use of links that we've already seen a little bit earlier is as a layer reference in the layer source attribute. This usage of plain undifferentiated opaque URLs is vital to gain the advantages of simple sharing of information over the web. No API, apart from that of HTTP with its standardized media types, should be needed to access map content. We hope that it will be possible for browsers to treat such URLs in a way similar to how they manage a URL to an image or video file. In those cases, the browser synthesizes a simple HTML document around the resource and renders it. It's hard to summarize in a few sentences about how important this feature is, so I won't try. I did a lightning talk about this idea a few years back, and that tries to explain some of the reasoning, which I'll paste into the chat window now. Next, layers may refer to externally defined legends using the link rel equals legend link relation. This is an extension of the supported link relations in HTML and reflects the use of legend links in WMS. It might work similarly to the rel equals icon link in relation link relation in HTML, but it might also need more specifying in this proposal. If map widgets supported a legend control, this link could be used by that control. If not, the URL of the legend is available through the DOM or possibly through another high-level API. Next, the link rel equals license link relation with associated title attribute indicates the licensing and attribution associated to the map content. So part of the proposal is also for to implement alternate styles as sort of defined by name styles in the WMS specification, and this would be done by a series of essentially alternate links that would be characterized by the style rel, and the style that is that identifies the current style of base map would have the additional rel value of self style as shown here. So this allows you to simulate, like in Google Maps, for example, satellite or map view or hybrid view kind of thing. So a key value of links in HTML is to refer to, is to separate content from presentation rules in style sheets, and that is supported by the proposal for map content and style sheets relating to map content. And so there are a small set of projections that are supported by the proposal currently, and rather than asking browsers to fully support projection transformations, we propose an alternate mechanism for negotiating projection through a link relation of alternate with a projection, an added projection attribute. So as a map defined by the browser would have a defined projection, if someone tried to add a layer that didn't match that projection, it could say, well, if the projection didn't match the map, it wouldn't allow it to be drawn. It would just be inert. But if the incoming URL supported or content supported alternate projections, it would simply follow the appropriate alternate and use that instead. So there are link relations for meta references. So tiles, images, and features. Feature and image are essentially synonymous, but they probably should be factored out into media types. So consolidate the tile and extent or some other tile and map link relation and distinguish between images and features by media type. And then we've implemented a kind of link that allows you to set up like a zoom in relation or a zoom out relation, so you can transfer the source of the layer from one data source to another, depending on whether the user zooms in or out. And that I think that needs to be have more work done on user interface and so on, but it seems to be pretty functional. And then we have the query support for feature query, and that it's set up by a link relation of query, and it's fed by inputs and so on per the location inputs and zoom inputs and so on, as per the content content requests. And I'll show that a little bit now. One of the fundamental use cases of maps is to identify the properties of a feature of interest. This is supported in many standard geospatial APIs, both on the server and client. One of the key challenges of this use case is to make it accessible. What's shown in this short clip is a keyboard user manipulating the map extent and using the keyboard to interrogate the top layer at the center point of the map. In the example, a single feature element with a polygon geometry is returned by the server and drawn on top of the map, highlighted in yellow, with no fill. The properties of the feature in the response from the server is loaded into a browsing context. In this case, the context is confined to a pop-up balloon. The OGC Simple Features model is the most successful standard in OGC history and is the backbone of the spatial data processing industry. And on the web, GeoJSON is the most appropriate current standard for encoding it as text. HTML is arguably the most successful standard in history. While it's not the intent of the proposals to suggest that all features in maps should be represented as HTML elements, it's a natural step if we're going to create maps in HTML to create a browser renderable version of the simple features model in HTML that supports markup of the earth and objects in real and hyperspace with the same technology and for the same reasons that human text is rendered as markup in HTML, as stylable, accessible hypertext. The proposed feature element would be a natural DOM representation of GeoJSON content in that its properties element could contain arbitrary standard HTML. The geometry property of the GeoJSON feature object would be represented as semantic markup, with sequences of coordinates elements representing corresponding coordinate pair arrays in the GeoJSON property. The native zoom or intended scale of the feature and its properties is represented by the feature zoom attribute. The coordinates are in horizontal axis space vertical axis order, that is commonly referred to as XY order. I don't refer to it as such because there are several associated coordinate systems in a TCRS and it should be legal to represent geometries in any of them, and the coordinate system used for a geometry should be identified by the geometry CS attribute. The geometry content model is based on the standard OGC simple features model, and so it's not unlike KML, GeoJSON, shapefiles, and many others. It's intended to be fully selectable and stylable with CSS, and linkable in a way similar to human-readable text. This demands a mixed content model for geometry coordinates. Sharing the simple features geometry model of so many formats means that there are many existing libraries that can be used or easily adapted to serialize it. Moreover, since there is a negligible impedance mismatch between this and GeoJSON geometry model, styling and rendering is simplified and will work with any JavaScript process that already uses GeoJSON. Having a CSS selectors compatible component model means that CSS can be used to render, for example, tiled vector content in an efficient and standards compliant way. Links embedded in content are the feature that sets the web apart from all previous and future platforms. Web maps should use this facet of the web to enable federation of services in the same way that HTML pages are federated. You link to the thing you want people to go see. The same should be true of web maps. A web cartographer should be able to link to the thing that should replace the layer or map the user is looking at when they activate the link. Links, while stylable, should hit the GeoWeb with a predefined canonical style and accessibility behavior so that users recognize them as something they are expected to activate. Activating a link should replace the current browsing context or with the link to layer, or if the response is text HTML, it should open to a new top-level browsing context, or something like that. The proposal started off with actual tile elements, and they still respond to requirements for static map documents. This might be a way in which custom renderers could be managed. The developer could set up an event cycle for tiles which they want to be responsible for the content, be it a canvas, image, or other thing. The browser could generate the tile for the developer, handing them the painting surface when appropriate. The browser would still be responsible for tile lifecycle management and could even create a local tile cache so that once painted it could be reused. When the link rel equals image construct is used, a request for an image to cover the extent ensues. This image is currently rendered at 0, 0 of the map coordinate system because currently we can't rotate our maps. So the image fills the entire viewport in both dimensions. Generally, the implication of this is that a virtual image element is created and rendered at an absolute position in the TCRS, and the image covers the entire viewpoint, possibly with hidden overlaps outside the box. This could lead to a useful concept. Arbitrary HTML, including SVG of course, should be renderable on a map layer, just as map tiles and features and images are. This would be a great help with cartographic communication, as maps often have embedded metadata, and this could be a natural and accessible way to include that. A key feature of spatial data infrastructure is the ability to use in place, without copying, authoritative data. This was what gave rise to OGC Web Services, which will eventually give way to OGC APIs. I note that this aspect of the proposal is similar or related to that of Takagi-san's svgmap.js layer concept. A key feature of the web is the ability to share stuff using plain, undifferentiated, opaque URLs that are intermediated mostly by web browsers. The idea of sharing here is broadly defined to include, among other things, links between documents, links to media resources, bookmarks, separation of style from content, inclusion of script to extend behavior, etc. The proposal began by specifying MapML as a vocabulary in micro-XML, based on the author's evolving understanding of how to propose stuff for compatibility with HTML. I now realize that I went a little too far in banishing all namespaces and XML syntax. We should have started with the XML namespace and syntax of HTML5. I believe we can easily fix this by adding the HTML namespace to our XML serialization, and the plan is to add an HTML parser compatible version when appropriate. Just to be clear, the doc type MapML and the MapML element shown here is not HTML parser compatible today, and we need to close the issue on that conversation before moving forward with the HTML syntax idea. In any case, the core idea here is that including map content should be about as easy as including a video, audio, or image by using the layer source attribute as shown to point to MapML content.
So what does it mean for a map to be accessible? Robert Linder and Nic Chan contributed to that discussion tonight, and Robert has been helping to make the web map custom element more accessible. But there's more that needs to be done, and we welcome new contributions and contributors. My hope is that by allowing websites to represent the physical world in a standard way, it will be a first step in enabling augmented reality for users, much like what we saw the dream come true earlier in Brandon's presentations. That is, by defining standard geospatial markup that is understood by browsers, you enable browsers to read the world, which is appropriate support for users. While the declarative form is less powerful, i.e. not Turing complete, it isn't necessarily simple, as we've seen. Simplicity, however, is a goal, and one that is in tension with sufficient function. The ambition of the proposal is to define enough to be a solid and performant foundation or progressive enhancement, while not trying to replace the ecosystem of geospatial web developers who create and use maps. So animation is obviously something that hasn't really been considered yet in the proposal, and that's something that we should factor into future discussions, you know, as a thought process, as mentioned by Doug.
earlier or yesterday. That the thought occurs to me that we need to have the ability to create geospatial content using web browsers. And so that would lead perhaps naturally to repurposing the input type location to serialize the different simple features, geometries in forms that were associated to map layers. I think the DOM API is of elements and attributes is already, there's already pretty elaborate ones specified here, but is there more that we need to specify? That's an open question. I think what we need to do is to build web mapping applications using the polyfill to examine exactly what web developers will need to progressively enhance that. And so could the DOM API as sort of envisaged be a foundation for, version, I don't know what version of open layers is at, but the next generation of open layers could be more readily and performantly and compactly built upon a web map element and layer element. And what would that look like? I think the objective would be to make that easier and more maintainable. And how can we build cartographic requirements into CSS? That's a conversation that is very much we're very much interested in having. And could we add 3D rendering through something like a map with projection equals globe attribute, so that with geopose like starting conditions. So we're going to hear a bit, quite a bit from the augmented reality community, and the geopose community in particular could help flesh out this concept. So cores, security, I'm not a security expert, but there's obviously lots of security implications in layering content vertically in the browser from different domains, and a lot of risks. So that needs to be thought about and designed, and maybe we need to find out if there are showstoppers in there. So queries could be met, like when we see the browser interrogating polygons on the map, that's a cores situation as well, because you're receiving content from over the web. As currently envisaged, a map document would not have executable JavaScript in it. So, I mean, that's maybe one saving grace, but to be determined. And the HTML parser should be used. Because of the MapML document requirements, this seems to be a challenge. So when SVG is parsed and referred to by an image source attribute, seems to be a similar scenario. So as described. And so that's all I have for my presentation. I'd be happy to do a demo or answer questions as we go along.
So I think we've had some questions coming in on the chat, so might be worth going through a few of those, although I was also hoping you'd have time to play around with your polyfill demo.
Yeah, I'm set up for that, so maybe talk a few.
We've only got a small group, so people can probably jump in and unmute themselves when they like, but to start it off, Fred Esch commented earlier on, why are you reusing input element? Isn't HTML input already complicated enough? And later, problem with reusing element names that exist in HTML is it confuses validation tools that already have problems with SVG. And MapML will make that worse. So Peter, you and I have had many conversations on this, so you know my opinions on it, but do you want to kind of explain the thinking that led to the current proposal and what can maybe be done to change things if needed?
Well, so input, I mean, we're not reusing, we are using those, we're proposing extensions to existing elements. So the notion is that this is part of HTML. So every new attribute and every new element is a proposed new attribute and element in HTML. So yes, that's a challenge because of the expense and effort of doing this. But I believe that the HTML design principles suggest that you not create new markup forms where, you know, there is already an existing markup form for a given semantic. So there are lots of ways to think about that. For example, they didn't invent a new image element when they went to provide responsive design for images. They looked at, well, where do images come from on the web, and where do we mark them up in the web, and can we provide a new interface for that is understandable in the context of images? And so that is the reasoning behind using or targeting the input element. So yes, the proposal would probably benefit from a nested new type of input, like a button or something like that, or like a map location input that you could factor out axes into different elements and so on. But HTML already has inputs. And so like anything, you know, some people hate them. Is Brian Cardell still on the line? Some people hate them.
Inputs are form elements. And working as an accessibility person, getting developers to do something totally different in this other sense, they would pick up attributes and it would be a nightmare keeping them from using wrong attributes and wrong in the wrong place. And your validation tools are just going to go nuts. So I really hate that idea myself, but.
Well, I did fork the HTML parser and create a validator, create the validator for the MapML vocabulary. And, it's possible. Of course, it's not the only validator on the planet, but, when you do make changes to a language, you want to make them in the right places. So seemed to me that
the W3C validation service has problems with embedded SVG, giving you false negative failures, and that'll just go nuts.
I don't think that we should. I don't think that we should predicate any particular enhancements on what existing tools on the flaws of existing tools. I know the SVG parser, the SVG feature, or the SVG validation in W3C's validator is not very good. That's a flaw in the validator, not in the proposal. Now, it's not that I disagree with you. I'm just saying, let's not say that just because one tool does something poorly, that we can't do something else, right? We shouldn't be predicated only on tools.
Yeah, so anyhow, my understanding of the HTML design principles is that you should look for a semantic entry point for making proposals for changes
Yeah, but an input is a form element.
Yeah, so as I described, the extent is a new type of form element. So extent is
user input?
No, like a form. So a form is not a visible kind of construct. So nor is extent. Extent is the conceptual rectangle of the viewer's viewport and for the map, and that rectangle is bound to the extent element and the inputs and links that are children of that extent element. So the extent element provides a scope, let's say, for the inputs and links that are in it, in the same way that the form element provides a scope for inputs and the action attribute, the single action attribute to which it is directed. You know, the difference between an extent and a form, you know, I mean, there's an overlap in the idea at least, but the differences are that the extent could have more than one URL to which it makes requests, whereas a form is bound to the action value.
Yeah, I mean, there is a core similarity in that form and form inputs are used to access a possibly infinite set of possible URLs by building up a URL from parts based on the user's action. And in that way, the extent and the inputs that's in Peter's proposal, they are used to build up the possibly infinite combinations of URLs based on the user's panning and zooming of the map. And so there is a logical similarity there that, you know, the form inputs define the sort of parameters that a database query accepts, and the extent inputs define the parameters that a map server accepts.
Yeah,
But with that said, I see the logic of it, but I also very much agree with Fred's concern about just reusing a very overloaded element.
Yeah, I even though I don't think we should predicate things on existing tools, we can't even get the new input elements implemented for common things like, I don't know where the calendar is, but there are several inputs that are not interoperably implemented. So several of the new HTML5 input types are not interoperably implemented in browsers, and that speaks to how willing browsers are to fiddle with these new existing tools. So I agree with Fred in essence, although I think that overloading input at this point is probably asking for a lot from browsers, even though I understand logically, like there's a certain elegance to it, but it becomes less elegant when you consider how overloaded the different input types are already. And again, what that does mean for not just parsing, but actually adding behavior to them.
Mm-hmm. I mean, I'm sympathetic, but I also would hark everybody's attention back to the HTML design principles. And like, if there's something that does what an input does, which is provide a variable value to a server, should you go around inventing a new mechanism for that in HTML? Like, I didn't feel like it was my place to say, this is the new style of input that HTML expects. I said, we said inputs are what they use today. So, like, unless you're freezing HTML forever,
I think that I totally get where you're coming from, and theoretically you're correct, but I really think you need to look at the recent history of extending markup within the HTML group, and there's definitely strong resistance to changing things about inputs at this point. So even though you're theoretically correct, and even though long-term it might be the better solution, the extent to which you're changing the inputs makes them much more complicated to implement. It might just be easier to try to find another mechanism.
Yeah. Well, if another mechanism would fly better, I'd say sure, no problem. We can redo that proposal, part of the proposal. But anyhow, I'm saying they're like inputs in forms, and we need to maybe start the debate at that point. Not, well, you can't do inputs because we hate them. Well, so inputs are dead.
Just to change gears, Google Maps uses a zoom level and a center point, and it's pretty simple. Why do you have a different way of doing your defining where your map is? Because they're using raster tiles.
Okay, well, that was in part 1, Fred. So yeah, we have the same simplicity. We have map zoom equals whatever, lat equals whatever, long equals whatever, and that's your starting conditions for the map.
Okay, I thought I saw that, but I thought today you were talking about corners and all sorts of stuff.
Well, I mean, I'm talking about how the logic for getting content into the map works. And that's pretty important when, these maps are, hundreds or thousands of gigabytes. Ivan, you've got a question.
Yvonne, are you muted?
Maybe you have to acknowledge the hand in this this thing. I can do a demo if anybody wants to see that.
He doesn't seem to be muted, but we can't hear you, Yvonne.
Yeah.
Oh, no, he's gone. Oh, no, he's not. There he is.
Your microphone's not working? Sorry, man. Oh, you're not plugged in. You want to type it in the chat? Type your question.
No, still nothing. Okay, we'll switch around. Brian, you mentioned you had some questions. And hopefully...
Hi, yes, I do have a couple, so stop me if you feel like I'm taking up too much time. Is it okay if I share my screen just super fast?
Mm-hmm.
So you're probably predicated to this question. You probably know it's coming. So a lot like what you just said, essentially what we have is forms, and we used HTML form to build into an API in a database so that you didn't have to write JavaScript to do it. So we came across a lot of those things, what are primitive, what is something that needs to be known, what type of thing is being saved by the form, who's the person creating the form, what's the motivation for it. That's a very web annotation thing, don't worry about it. But really specifically was being able to provide context. So I saw that you had a lot of link sort of primitive things in one of those very early slides you showed. And I was wondering if you had considered one of those for supplying schema, sort of like an RDFS XML style schema, or even like a JSON LD context like this. That's my first question.
Out of my scope of expertise, frankly, Brian.
That's okay. I was just curious because all it is just, here I have an array of them, which is a whole nother thing to start to talk about arrays as attributes. And you can see here, like you're proposing, you have to implement some kind of syntax and take away some kind of delimiter from the user to make sure we can parse these things correctly. And that just turns into a nightmare. So I'm really curious how you're going to express hierarchy in those coordinates, which is my second question.
Well, there are arrays of coordinates elements, so.
Oh, I see. So you're going to use the element itself.
Yeah. So the coordinates element is the deepest child. Well, I mean, I guess in my proposal, you would be able to wrap spans around coordinates and hyperlink anchors around coordinates or around, parts of coordinates.
Yeah, I got you.
So yeah, the coordinates are basically the lowest level element, and you could, so you could style different rings differently or multiple times, I guess.
I see, I see. So it's not, can you like nest a coordinate element in another coordinate element?
No,
No, so
no,
that's
it's
what you're
based on,
stopping. I got you.
based on GeoJSON, Simple
Yep.
Features Model, KML,
Yep.
all of these formats have this similarity that way.
Yep. Good. That's a good answer. That's what I was looking for. Good. So then I guess, whoop, oh no, can you still hear me? I pushed a button.
Yeah, we can hear you.
Okay. So when you did that doc, so this is something I just have no knowledge about. When you did that doc type MapML, was that sort of your way of telling the browser developers I'm using that markup language schema? Is that how at that level you were like, hey? So
the purpose of the doc type MapML in concept is it's like the media type. So it's a second level of processing that beyond the media type. So when you exchange messages on the web, you have the content type and the accept headers to dictate media type metadata.
Yep.
So you could say text HTML is this text MapML is this response to a source attribute request.
Oh, okay.
And because that's in a layer element, it gets drawn by the renderer in the coordinate space that is set up as a layer.
Okay.
But when you so just to fit into the HTML parser, the HTML elements have void syntax, and some of them are, there's an idiosyncrasy to HTML that you would have to follow. Like if you use inputs, for example, if you extend inputs, they are a void element, so you have to have a no closing tag, for example. And so a doc type MapML would be like a mode, so that when you load an SVG off an SVG URL, you've got the SVG media type to guide you. But when you load it off a file system, there's not necessarily the right media type, and they're mapped to different file types and stuff like that. So the browser would needs to have more clues like that are in the document. And so, I mean, we haven't closed the loop on this conversation with Simon and the WHATWG experts, but I'm still pushing for a doc type MapML as a sort of a second tier of media type indication.
Yeah, that makes, that makes great sense. I just, I've been developing for 10 years doing doc type HTML at the top and never asked anybody why I had to do that.
Yeah, I think it's like a processing mode for the parser. Simon could definitely give you a couple of hour discussion on that, but they don't like to change the parser at all. Even adding new elements, I guess, makes them nervous. So adding new modes is like a double nervous. So anyhow, we have to walk that line.
Yes. So my last question's a softball, because I just need you to point me to the right place. At some point, you had to write, I'm using, feature tag. Here's the vocabulary for that feature tag, or something, some description about it somehow. Where is that, so I can sort of kind of get a better idea about the exact definition of the elements you use?
Yeah, so that's the MapML specification, which is evolving, let's say. That's what I always say, my standard.
All the good ones are. That's how we do it. Keep things open,
position.
open minds.
So in the Maps for HTML community group on GitHub, I'll paste it into the chat here.
Yes, please.
There is the MapML repository, and you'll find a link to the spec for that. And in there, there are some things in there that are probably a bit confusing at this point, because it's a challenge for me to do everything now, keep it up to date. Yes. Robert Linder is keeping me on track here, because he's got a very sharp eye for detail. So it'll probably come up to speed again soon, but you know, we're talking about the proposal in general here, not specifying it at the moment. So maybe I'll just do a quick demo if there's any more time.
Yeah, why don't you take the last 5 minutes unless anybody has urgent questions?
Share screen.
Do you have any support for a
Ron
gazette?
typed his from earlier. Sorry.
Not part of MapML.
What was the question? Sorry, say again.
Do you have support for a gazetteer, geographic names?
Like is it it's a kind of a query interface, right?
Yep.
Oh, no support yet. Not specifically anyway. So
Peter, Yvonne had a question to see the audio prompts before they.
okay, yeah. Yeah.
Let me scroll back and find it. The use case for not specifying map view as center zoom, a lot of people want to specify maximum map bounds, e.g. display at most 180 degrees of longitude as MapKit does. Sorry, and a casuistic? I can't.
The use case for not specifying map view as a center zoom is that a lot of people want to specify maximum map bounds as a starting condition, you mean?
So there's the option of setting B-box, bounding box dimensions instead of just the center point. And actually, Takagi-san also was commenting on how bounding box can be a lot more flexible than zoom levels, which only have, you know, integer options, but with a vector graph, you don't need to restrict yourself to the title levels. You can have continuous zoom.
Yeah. So we have the concept of extent for a layer, so you can set the extent for a given layer, and then I think that you could simulate like zooming, like a B-box starting condition by zooming to that extent, like having a zoom to extent thing. Is that good enough? Does that give me a thumbs up or not? So let me share, and I don't know if where we're at in the evolution of the polyfill will help us share this guy. So this is the polyfill, and it's based on a leaflet, and it, you know, a modified leaflet. Well, not too modified, actually. It's pretty raw leaflet, but we extend our thing, and it allows you to, yeah. So the starting conditions are like currently based on lat long zoom, but you know, the geopose and so on, they have, they've got some
Peter,
sort of.
can you cut your video? I think we're getting your audio breaking up. So.
Cut my video, stop my video, yeah. Can you hear me? How's that?
Better.
Much better.
Okay, so if I just, we've got a little menu set up here. So the debug mode, it shows you the extent of the layer outlined in red, and it shows you the tile grid. And so we have the properties of the map, and are set up. Let's see, view map source stuff. So the properties of the map of each layer has an extent property. So you could have so the coordinates of the corners of the extent are stored in that. I'll untoggle debug mode. Just reload. there, if I F12 and I select the elements, the layer itself has an extent property that that has the coordinates of the layer in top right and bottom left in all the different coordinate systems associated to the TCRS. And so, like, I think there's a zoom to function built into Leaflet, and we copied it into the map element as an API type of thing. So you could calculate the center point of that bounding box and zoom to that. Zoom. We haven't got the zoom to layer thing, but the plan was to fit that bounding box at the maximum possible zoom onto the map as possible, and then zoom to that. So that was sort of like bounding box starting conditions, but I mean, then you would have to save the starting conditions as lat long zoom in the current proposal. So that's sort of the best answer I can give you, Yvonne.
I'm not sure. Can I intervene a little? So
Yeah.
are you referring, because like this is in the beginning, you will zoom to a specific location, let's say a city or a neighborhood. But I'm not sure if the question was more, okay, maybe indirectly, let's say New York, you zoom in Brooklyn, and the maximum extent that you can zoom out would be the surface of the city of New York. You cannot go to city or country level. Is this about, or?
Oh, I see. So you couldn't zoom out past that.
This, like, there is use cases for like cities or other things like that where you don't want users maybe to go.
Yeah.
And I said I shared the link in the chat for like an example what I'm doing now for a city in Cluj-Napoca for an event where you have a maximum zoom, because it would be unuseful for them to zoom out more because it's just for the city.
I guess there's no declarative means for setting that up right now. I mean, we'd have to think about how you could do that using the DOM API for this thing. So like check the properties of lat long zoom and compare them against your preferred thing and prevent that event from occurring. I'm not sure if is that a progressive enhancement, or is that something that should be built into the declarative function? That's a question, not a statement.
Yeah.
So yeah, just quickly, I've got GeoServer set up. So we've got we've got a version of this built into GeoServer. So if you've got different data sets in GeoServer, you can serve them. It'll serve them in the MapML projections that you specify. So there's WGS84. And the projection negotiation deal was we take that WGS84 layer and we drag it onto the map, which just adds a layer element to the map DOM. And but it's got the curved shape of the Lambert conformal conic. So it's not doing any projection transformation. Well, GeoServer's doing all of that stuff. So the server side content management systems are still whatever they are. But and so that's the projection negotiation deal, and it'll do, like, I mean, it works pretty well for WMS and tiles and stuff. I mean, it's a basic system. So what I was showing you earlier was the ability to query it at particular locations, and that is actually, the GeoServer is returning a MapML document with the map feature in it for the shape of Texas, and the properties are shown in a leaflet pop-up, And I guess in lots of modern web map frameworks, they've gone from pop-ups to pullouts or whatever. So one of the challenges is to think of, okay, well, how could we allow a web developer to say, I don't like pop-ups. I wanna have a slider or a slide out kind of thing, or a slide up, that kind of thing, and capture the event and do that for themselves, so that the web designer has their own ideas of how this should be handled or what should be pulled out of it. And I think Amelia and Brian were both referring to how difficult a challenge that is. But there should be like a default, like the user agent would provide a default way to do that. And if you want to capture the event and do it yourself, well, you have the feature data to do it with. And so yeah, it's on. That is available on GitHub as the web map custom element, and there are releases of it, and we should probably get a new release out. But you can just, it's not on NPM. You just have to download it and unzip it, and it should work. You should be able to use it from a web directory. So yeah, you don't have to have a geometry associated to a query response. You can just get an HTML file back like you do here. And the remote document is a simple view source type of document. And you can add layers willy-nilly to this thing if you want, if you so desire. I mean, there's a limit. But so a layer is, like Ivan said, everything's a layer. So a layer could contain templates. So a layer can't contain other layers, but a layer can contain as many templates and as much content as you want to put into it. And those templates should be, well, they are part of the DOM, I guess, and you should be able to change their Z index, by moving them around, by changing the Z index and so on, same way that you do in any other part of HTML and SVG. And apparently Robert Linder was showing me that I've broken the back button on this web page, and it needs to be updated. But I was trying to just sort of bookmark pages so that you could, when you copied a location on the page, you could go send that bookmark back to somebody, and it would go to that point, and it's not doing it. So it's broken, and I wrote the back button. But anyhow, that wouldn't be built into the map element itself. It's really part of the HTML author's responsibility, right? Because you could have 5 maps on one page, and which one would get access to the URL is an open question. So what else is there to show? Well, again, the MapML extension to GeoServer, you can set it up so that you can serve it as tiles or a WMS. So, for example, for the imagery layer here, North American imagery, that would be good to. No, hang on. Where am I going? Edit this layer. So publishing. So publishing, there's a MapML panel, and you can say use tiles, and that will just use WMS requests over the thing as tiles, or you can actually set it up to cache the tiles. So if I have particular like OSM tile and WGS84 and CBM tile, I can set them up, and it caches these things on the first use automatically. And then so when I go to layer preview, these tiles for the imagery, it should come in tiles. Yeah, you can see the tiles showing up. So that's being done by the GeoServer on the back end. So this is like geospatial content management systems. could be equipped really quickly to start pumping out HTML, MapML, and you know, we would have like a content universe on day one of this thing appearing in browsers. So that's my pitch.
Can I ask a question regarding MapML and regarding, like, I don't know if you know turfjs.org, which is you can do a lot of transformation or things like that, and they have things like buffer or other. This would be something that maybe probably not now, but in the future could be built in. So the idea is if you would have different points that they would have different values, like population of cities or other things like that, they could scale based on that, like using a buffer or for selecting elements inside like 300 meters videos.
I think that these could be like managed by the API, you know, like, so you could have like developers, the developer ecosystem still should, I mean, the browser engine can't do everything, right? So the developer ecosystem should be just facilitated by the proposal, not replaced. I mean, I guess there's a certain amount of rendering responsibility and so on that could be replaced, and it would probably be welcome. I don't know for sure, Yvonne and Andreas, but my sense is that the rendering is a full-time job. So yeah, I mean, I would encourage like progressive enhancement is the way I describe it. I don't know if that's the right term, but having an API upon which you can build is a core value.
Of course.
Mm-hmm. So I guess that's about it. Unless people have more comments, I'm happy to take questions. I'll try and go through the chat if there are questions in there and comments and respond.
I do have one last quick one if you're all right with it.
Yeah, please.
So something that I have a ton of trouble with in Leaflet is like, say I've got a bunch of points. There's no like way for me to say, I only want to see those points that have this property. Like to do that in Leaflet, you have to write a custom JavaScript function that goes over every layer and find the features and read the properties out, which is an extremely expensive function, as you can imagine. Mm-hmm. So I saw you like doing some filtering with layers there because you were doing the checkboxes. Mm-hmm. Do you think you'd be able to sort of filter, you know, hide show features by properties kind of thing?
Well, so I think that is like, well, that was the, so that was the,
and, you know, I could see that being a, well, when we have the API, that's the kind of things we'd like, you know, to be able to stick into the API. I'm just curious because that's something that you just really cannot do right now with like the Mapbox and Leaflet stuff that's out there.
So, well, it's, I don't have a magic bullet, but let me share my screen. And so this file here was the, has a select element in it. And I think this is an area that needs more research and collaboration. Yeah, so in this select, it's called the year select. And I've got a bunch of ArcGIS WMS layer IDs separated by commas because that's their way of parameterizing their WMS is by layer IDs. And then I tied that, you know, those layer IDs on the server. This was set up after someone had already set up this data service. So they said, okay, well, this is the list of layer IDs that in that order that constitute 1867 and so on. And then as the you know, the user can query that that file by clicking on the control in the layer list, and they get a different query against the server through, you know, and so now whenever I'm panning and zooming, I'm looking at 1874, right? So it's looking at that as defined by the server. So I mean, I think there's probably a lot more to this, but anyhow.
And the different values represent each count, each kind of state, or is the order, like the layering, like this is the top, this is middle?
Yeah, so like layer 17 is the labels, and layer 12 is I don't know, Ontario, or the polygons, and another thing's the lines, that kind of thing.
But if there would be like over Ontario, there would be another layer like showing the trees, it would be rendered before or after, or it could be this set, or is like how the engine render it, like random, or it would be considered.
Like in terms of the DOM order?
Yeah.
So if you add another layer element into the map element as a child, it just draws on top, just like just like the image maps, right? So
okay,
the image map image element draws as the base layer, and the areas draw on top of it. So they're in DOM order, I guess, sort of like the layer elements in this. And so by default, the layers in this thing are drawn in document order down the page. But let's say you wanted to have like a GIS solution where you have the layers stacked up on the left or something like that. You should be able to shut the controls off and make your own controls using HTML. You know, just like you can do with the video element, right? You receive events to control and stop the video. Well, you should be able to get these events off the map element and do the same thing. So you just get a boost in performance and so on off the rendering engine.
Yeah, that was a good analogy. Thank you.
My pleasure. I hope that helps. I mean, I think this is just an area we played with a little bit. I think there's, you know, that's why inputs, Fred's probably not on anymore, but this is why inputs could be like a useful thing to work with here rather than reinvent, even though everybody hates them. Let's see. So, yeah. Yeah. Satoru-san says in svgmap.js, I made this kind of custom form functionality free to design in the web apps, assigning it all to each layer. Yeah. So that's sort of the same approach, but we haven't played around with it too much here, other than to say the controls, you know, from the controls that are oriented to the user interface are directed towards the layer control, and the controls that are location specific and zoom specific and width specific are hidden. Essentially, they're invisible. And yeah, so we would really love you to play around with this and give us comments. I apologize for bugs and stuff. It is my fault. So we'll iterate though.
Good. Well, the most important thing to take away is your direct contact then.
Yeah.
Yeah, and all the MapML stuff, both the spec and the polyfills, are on GitHub, and there's open discussion, and join the community group. And
yeah, so Yvonne said, ideally the DOM scripting interface would have the same functionalities as, say, leaflet open layers. So stuff like custom tile buffers could be in. Yeah, absolutely. So we would like to, yeah, for sure, for the sophisticated stuff that, you know, cutting edge, let's just leave it to the ingenuity of web developers to fill in. So yeah, leaflet, the core model of leaflet, like the core and extension model of leaflet is what sort of inspiring in terms of what should be in versus out. I mean, there's stuff that you, even in leaflet, as cut down as it is, as core as the core is, there's still stuff that, you know, the HTML guys are not gonna like. So we gotta think hard about what is in and what is possible.
Okay, we're about ready to wrap it up then, Peter? 'Cause I think we've already gone well over time.
Yeah, sorry.
So there's lots to talk about.
Yeah. Okay, well, thank you very much, everyone. Thanks a lot for going through this with us. And
Cool. Thank you, Peter.
Thanks for organizing.
Great.
And we'll see you all next week. Same times and days as it was this week, but you all have the agenda.
Great. Thank you and good night.
Or good morning.
Or good morning. Yeah.
See you, everybody.
Bye.
Yeah.
Bye-bye.
Thanks, bye.